We're talking about the data lake value proposition for the medical data processing company. And basically, our agenda is going to be what is to understand a data lake, the components, the difference between data lake and data warehouse, the business value proposition, and the architecture we are going to be going with. So this was done so we, due to the problems the business was facing with scale and the volume of data coming in. So basically, a data lake is a central repository where all the company's data is stored. This can be from the different database, both external and internal sources, and this can be from files like CSV, TXT, all pipelined into the data lake, and it's processed and transformed within data lake, for processes like analytics, reporting, and even machine learning stroke AI projects. A data lake is scalable, it runs on the cloud, it makes use of the different cheap servers that are available on the cloud, allows it to scale horizontally. So what are the components of the data lake? Data lake will be made up of several component layers, and these layers are required for the data to be usable and accessible for the end users. So first of all, there's the ingestion layer. Here it involves extracting the data from the sources. So like I said, the sources can be an SQL database, can be a file, a CSV file, can be an API, and all these data are pipelined into the data lake. Storage layer is the layer that receives the raw database, the raw data. This can be both structured and unstructured data from the different sources. And the processing layer, this is where the data is transformed into a usable form. So the data might come in some unstructured, some can be usable, you can't really interact with it because it's nested in like a JSON format, or the data is not in a queryable state. So you need to process it, transform it, clean it, some missing values. This is where all that, you prepare the data more or less. Then the serving layer, now you serve the user. This can be via a dashboard, for analytics purposes. It can also be a report, like a PDF report. You can have a system that generates a PDF report for the end user, or you can have like your team, your data science team, interact with this data, for AI, machine learning use cases for the business. So this data will be prepared and made readily available for them, which would open the business for more opportunities. And so next is, what's the difference between a data lake and data warehouse? Because there's a lot of similarities, but for a data warehouse, it's more or less like a database but the database has been customized for querying purposes. So say you have a Postgres database that has been modified so that the way it stores data, data can be efficiently retrieved. But the thing with that with the data warehouse is that both the compute and the storage, they are combined. So the database stores the data on the server, and the transformation also happens on that same server. And whereas with data lake, the compute and storage is separated. Storage can be on a file server, or on a file server or some sort of dedicated storage. Whereas compute is on a different processing server entirely from the storage, and you can scale the compute depending on the workload. You can scale the storage as well. You can scale them independently. With data warehouse, it's a bit more expensive to scale because you have to scale both storage and compute. That's what we call vertical scaling. You have to increase the size of the hardware, the CPU, the RAM, and storage. Whereas with data lake, you are, if the infrastructure is cheaper. It's cheaper to scale because you can scale horizontally. That means you can have multiple servers, multiple chip servers side by side. You don't have to increase it or increase the size of the RAM. Chip servers side by side, and you can store your data in partitions on these servers. But when you access them, you access it like a single entity. And same thing when you process it as well. You can take advantage of that partitioning ability. But with data warehouse, you have a faster query because the data is more or less in server. You can it's already structured. You have the abstraction in memory of your database server. So any query that comes quickly goes to the memory, and the abstraction layer is able to extract the data on the data warehouse server now. Whereas with data lake is the file is stored on the disk. So and the compute layer is separated from the storage layer. So those are two different servers. The compute layer has to access the storage server, and go through the data. It has to pull in the data, and return the query. Whereas everything is housed in one server, like the one data warehouse server, and it's faster. With the data warehouse, the schema is fixed. Schema, that means the structure, the the orientation of the data, because the columns and the columns of the data is you have to specify, oh, this is the columns you're expecting, these are the fields you're expecting. But with data lake, there's so much flexibility that allows you to you can change your schema at any time. Well, with the data warehouse, you can't change your schema. You have to modify the schema that the data warehouse is expecting. You have to modify the SQL schema so that you can accept the data that is coming in. Well, with the data lake, it's a lot more flexible. And data warehouses, you have Redshift, Snowflake. With data lake, you have HDFS, S3, and the compute layer being Presto and Hive. So this would the Presto and Hive works is the compute layer. The HDFS and S3 is the storage layer that works hand in hand to process your data and provide access. So the business value of a data lake, due to the medical facility dealing with high volume velocity and different variety of data. The data lake, we have like a centralized storage for all the data. There's no need to duplicate the data on different databases. You have a centralized storage where everything is in one place. You can scale cheaply, so if there's an increase in requests, it will be easy for the business to scale cheaply, saving costs. Instead of buying large servers to handle this data, we can handle different formats and different sources, enabling business to add more facilities to the system. So that ability to handle variety, a data lake is really suited for that. And that adds more revenue for the business. It's also fault tolerance, no downtime. If one node is down, another node picks up and replaces it until the other node comes up. So and the data is duplicated across the nodes. It's sort of redundant, so that if there's any downtime, there's always a backup to stand in place, and this will help avoid revenue loss. And with data lake, we can retain data infinitely, which is one of our requirements. One of the medical facility, one of the business requirements, to retain this medical data infinitely, depending on the requirements. And because we can buy cheap hardware to store this data, so it's also cheap to retain data and store data. So this would really save costs for the business. And this is what the architecture looks like. We can see the users. The users will access the web serve layer and the application layer. So here previously we had the SQL server, where we have Spark, Hive, Presto. We had the SQL server that was handling both the compute, the processing, the compute and processing, and the storage. But now we can see that the compute layer and the storage layer is separated. We have Spark, Hive, Presto. These are big data processing tools that allow us, process this data. They connect to the data source, that's the storage layer, and then run processes. We can also see the ingestion from the different facility. We have the ingestion layer, Kafka and Nifi. These are ingestion tools, both for real time and batch, and for file ingestion. These tools are scalable. They run on multiple nodes, that no matter the volume, they have high throughput, so fault tolerance. So the ingestion, both large and speed, both size and speed, this ingestion layer would handle it. And we can see it loads data into HDFS storage layer. The raw data receives raw data, then the processing tools transform it to the process format, which is served to the business. Analytics, reporting, dashboard, machine learning purposes. And we have tools like Airflow for orchestrating these ETLs, and more or less like a trigger. It triggers it once data is ingested. It triggers the compute, process it, and run ETL, and stores the final format in the processed storage. Atlas for metadata management. You want to know what fields you have. The sensitivity, does it contain any private information, personal information? And masking also helps to mask this data. Retention period, if you need to have a specified retention period for a subset, of data. This Atlas will help us implement that very well. And Prometheus, basically for monitoring and observation, both monitors both ingestion, the pipeline, ETL pipeline, and even the usage as well. We can implement this and connect it to our system. And yeah, so this year with the new architecture, SQL Server, the data in SQL Server is migrated to HDFS, and this compute layer and storage layer is implemented to replace the SQL Server. So next steps, firstly, we're going to build a proof of concept. Maybe we want one or two sources. Then we implement all the layers, the ingestion, compute, storage, serving layers. So we see how it works end to end. Then we decide with a hardware specification that really goes with for the different layers. We pick the one that would serve the volume that we are receiving. There's also the governance setup where Atlas will be useful to manage our metadata and compliance requirements. Monitoring and automation, that's for both the Prometheus, Grafana, and Airflow, would help us. Prometheus, Airflow monitor pipelines and the ingestions, and automation would make this on demand, without any need for human intervention. Then we'll go on to train the end users on how to access this data, those for analytics, those for reporting or machine learning. We'll train them how to access it. And the phase migration plan, that is, we are going to be moving from the SQL server to the new data source. So we can run that in phases, move the data in batches. So eventually we will phase out the SQL server completely. So that's pretty much it. That's how a data lake can be very useful to these organization. Thank you.